Go ahead.
Hey, all my favorite people. It's Mrs. Berger coming to you live from Larkspur Middle School, joined by
Mr. Lamb, also from Larkspur Middle School.
And today we're going to be talking about ratios, a new vocabulary word. Your I can statement is that I can write ratios using three forms: A to B, A colon B, and A over B.
Hey, before we get into the different forms, what's a ratio?
Well, funny you ask. A ratio is a comparison of two things.
Like pens to pencils?
Like pens to pencils, or like people wearing glasses right now to people not wearing glasses
That
right
would
now.
be a 1-to-1 ratio.
That would be a 1-to-1, right? Or like desks to students, or teachers to students, or students
so
to
basically,
teachers.
any comparison of anything.
Literally anything.
Any two things.
Any two non-numerical things that we can put into then comparing them numerically.
Ooh, I like that.
Yeah. So there are three forms or three ways to write a ratio.
So the first one would be A to B, and that's just using the word to. Like
Right.
as in 3 pencils, 2 4 pens.
Yeah. 3 to 4.
A colon B, again, 3 colon 4, 3 pencils, 4 pens.
Shows the same ratio, different form.
And then this one's a little weird because we have to use the slash, but it's really just a fraction. A over B as a fraction, which we can only use certain ways.
When it's a part to whole relationship.
Yeah, see, when you're talking about part of the group to the whole group.
Well, we'll talk
Number
about
of boys versus all the kids in the room.
Yeah, and we'll talk about that in a second. So here are just some examples of how we write ratios, right? A part-to-part relationship would be like boys to girls inside the classroom. Girls to boys, if I flipped it, still part-to-part. The main thing we have to remember, and this is super important with ratios, Mr. Lamb, is that the order we answer the ratio matters. So if it asks for boys to girls, I have to count up the number of boys, write that number first, then the number of girls.
So whatever they ask for first,
Yeah.
you have to write first.
The problem will tell you the order of the answer.
That's right.
Right. And then of course we have like boys to everyone in the class.
And that's called part to whole. It's just like this. This is the part, the boys in the class. That's the whole, all the students in the class.
And that's when we can bring in that fraction bar. So
And then there is one other one.
what is it?
Before you move on, it's like there's another one called whole to whole, but we like to call it set to set. And that would be an example of that would be like if you counted up the students in my class,
Yeah.
and then you compare them to the students in her class.
Yeah.
That would be set to set.
True. Sorry, I rushed through that one. My bad, guys. Alright, so now let's actually do some problems. So a ratio, whoops, wow, it's getting crazy. So we write a ratio when we're comparing two things, right? So our question is, what is the ratio of hearts to moons below? So the question tells us the order. So I want hearts first. It literally gives me the word two.
That's right.
Right? And then I want the moons. So the number of hearts has to go first to tell
So
the
then
reader
it would have to go 3.
the right number. 3. Literally the word two.
2.
4.
4.
And I could also write that 3 colon 4.
Could I write this one as a fraction?
No, you cannot, because this is what we would call a part-to-part relationship. Part of the shapes are hearts, part of the shapes are moons.
So there's
we
only
don't-
2 ways to write that.
Right, we don't write this one as a fraction.
Okay.
If it said hearts to all shapes,
Then we could write
then
it
I
as
could bring
a
in that fraction.
fraction.
Tricky.
So here's just a few more examples. Now this is kind of like a word problem example, right? It says Johnny looked in the desk drawer and noticed that there were 12 pencils, 6 pens, 3 highlighters, and 15 permanent markers. It says, so now we want to find the relationship between, let's say,
Let's do pencils to highlighters.
pencils to highlighters. So which one has to go first?
Pencils, because that's
So
what I said
pencils,
first.
she said first, so we got to do pencils first.
To the highlighters.
There you go.
So we could write that 12 pencils to 3 highlighters. And you don't have to write the words.
Is there another way I could write this and still be correct?
Yeah, I could simplify it, right?
Ooh, almost like when you simplify fractions.
I could simplify it just like I simplify a
So
fraction.
you could put it as 4 to 1.
Yeah, because what Mr. Lamb forgot to show you, because he skipped a step because he did that mental math.
Oh, yes, I did.
But for some of us that aren't as great as mental math, you have to find that common factor.
Yes.
And 12 and 3 are both divisible by 3.
Yep.
And just like where you divide the top and bottom to simplify a fraction, you divide the left and right to
Look at you
simplify a
doing
ratio.
all the math.
I know. I got to show your work sometimes, Mr. Lamb.
Now, this is a part to part again, right?
Right.
So we could have written it as 12 to 3 or
What
4.
are those things, Mr. Lamb?
That's the way I do. Sorry. I guess I should fill them in. They're really
Those
big.
are really big colons. Okay. Let's look at a part to whole relationship.
Okay, so same thing. 12 pencils, 6 pens, 3 highlighters, 15 permanent markers.
I'm going to have to do some math on this one, Mr. Lamb. I need a calculator.
Calculators are very good to use, and calculators are definitely allowed when you're doing this.
Where can I find a calculator?
Well,
Okay.
we could use a calculator, but let's just, I'll do the old-fashioned one.
We'll do some mental math.
So 12 plus 6 is 18.
18.
Plus 3, 21. Plus 15
is
36.
36. There's 36 total items.
So we have 36.
Oh, sorry.
We have 36 things.
There's 36
30
things in the desk drawer.
36.
This person's clearly a teacher.
Clearly.
Clear.
Okay, so we have 36 things, and we want to find a part to a whole relationship. So we know that after 2, it's going to be 36.
Let's do pens to total utensils.
Total
right?
things.
Total things, right?
I like
so there's 6 pens to 36 total things in the desk.
So we could also use that big colon.
We could be 6 colon 36, and because this is about all of the shapes, right? All of the, not shapes, all of the things, I could write that then as a fraction.
And then, obviously, if you look at this, 6 over 36, 6 to 36, 6 to 36, they share a common factor
of
6.
Yep.
Well, 2, 3, and 6, but 6 will get us there quickest.
6 is
So really, that could be 1 over 6 or 1 to 6. Or 1 colon 6.
Right? So we simplify a ratio the same way we simplify a fraction. You divide by a common factor.
Yep.
We can also expand ratios, but more to come on that later.
Ooh.
Yeah, don't want to give away everything in this first video. So if we look at a whole to whole relationship, right? All of one thing to all of another. It says 2 classes decide. It's okay. This is why we don't teach English, guys. 2 classes decide to battle each other in a math gym kit. Ooh. Mr. Lamb's class had 32 students, and Mrs. Berger's class had 30 students. So let's write the ratio of lamb to burger. Lamb burgers over here, right? So I like to sometimes, especially when I'm doing a word problem, write out the order that I want the things in, right? So that kind of gives me a key to now, I'm looking for Mr. Lamb's class. Lamb's class has 32.
So put it right there.
And then I just bring down that little 2. Miss Berger's class has 30. So then I can, boop, drop it down. Drop it like a top.
And of course, you can use the old
colon. But can I use the fraction bar?
No.
No.
Not a whole relationship.
No. Think about what a fraction means. A fraction is part of a whole.
It's part of some, it's part of the thing to all of the thing. And in this case, we couldn't do that.
I feel like I explained it well.
I thought
when
you
I said
did
part
too.
of the whole.
Well, you did, and then I had something flash through my head that wasn't very good.
Guys.
Now, could I reduce this one again?
We could simplify this fraction, but do we have to?
No.
Right, so a thing to remember with ratios, unless it says choose all of the equivalent, or to write your answer in simplest form, we don't really have
Well,
to
especially
simplify.
for this one, because this is comparing 2 whole sets. Kind of nice to leave it as the whole set.
Yeah, so let's not worry about it. I think we just go and move on. And that means we're done. So if you are confused on ratios, you're going to watch the next video. But if you feel like you're good to go, you're going to log into ClassLink and do that practice.